Okay, in this lecture we'll be talking about different types of goods. In particular, we're going to focus on public goods and common goods, or what are sometimes called common pool resources. So let's learn how to distinguish different types of goods. Now, goods differ in terms of their rivalry or in terms of their excludability. So if a good is rival, that means that if I consume it, you can't consume it, and vice versa. So if a good is non-rival, then that means that my consumption of the good doesn't prohibit your consumption of the good. And goods that are excludable, if a good is excludable, that means that I can be prevented from consuming the good, typically if I don't pay for the good. However, if a good is non-excludable, then that means that there's nothing anyone can really do to prevent me from consuming the good. In other words, I can still end up consuming it even if I don't pay for it. So let's consider a little table here, and we're going to divide it into 4 quadrants. Goods will differ in terms of their rivalry, so whether they're rival or non-rival. And goods will differ in terms of their excludability, so they can be excludable or non-excludable. So a good that is both rival and excludable is called a private good. Examples of private goods, maybe I'll do a little arrow here. Okay. Goods that are private, some examples might be, a McDonald's hamburger. Right? It's rival in the sense that if I consume the hamburger, you can't also consume the hamburger. It's excludable in the sense that if I don't pay for it, then McDonald's can easily exclude me from consuming the good. Other examples also include clothing and a congested toll road. Think about a road that is congested. So it's congested in the sense that if I get on the road, I'm preventing you from fully receiving the benefits of being on the road because I'm contributing to the congestion, I'm contributing to the traffic. And it's excludable in the sense that I have to pay for it in order to use the road. I have to pay a toll. Now let's consider goods that are non-rival and excludable. These are called club goods. Think about it in the sense that you're paying for access to the good. It's excludable. But we're both part of the same club. So long as we've both paid the entrance fee, then my consumption of the good in question or the service in no way prohibits or excludes you, or I should say is in no way rival to your consumption. So imagine some examples here. Satellite TV. Right, so long as we've both paid for the service, if I'm receiving that satellite signal and I'm watching TV at my house, there's nothing to prevent you from enjoying those same programs so long as you've also paid for the service. Other examples are streaming services like Netflix. So long as there's not so many people that it affects the bandwidth or something like that. Sirius XM radio, right? So long as we've both paid for the service, I can blast my music on Sirius XM in my car, and that doesn't impact your ability to play the music in your car. And finally, an uncongested toll road. So it's uncongested. Maybe it's I-75, 85 at 3 o'clock in the morning, right? There's hardly anyone out there on the road. And so it's uncongested. Me getting on the road in my car is not going to cause you any traffic delays or affect your consumption in any way. But we'll imagine, unlike I-75, 85, that it's a toll road, so we both have to pay to be able to use the road. A good that is rival and non-excludable is called a common good, or a common pool resource. And examples of common goods might be the stock of fish in a lake, or the stock of lobster off the coast of Maine, or the stock of fish in the ocean. Oftentimes environment or environmental goods, such as clean air, clean water, pastures, forests, the atmosphere, and also a congested non-toll road. So in this sense, it is congested, so each of us using the road is having an impact on somebody else's use of the road, but it's a non-toll road, so we don't have to pay for it, right? In that sense, it's non-excludable, but it is rival because of the congestion. And finally, goods that are non-rival and non-excludable we refer to as public goods. Now, some examples of public goods would be things like tornado sirens. I think about that. So we're both living in a town and we hear the tornado siren going off, right? There's no way to exclude me from the benefit of that tornado siren. I can hear it. Nobody's going to come and charge me and prevent me from receiving the benefit of that tornado siren if I don't pay. And it's also non-rival. We could be next door neighbors, and if I'm hearing the sound, you're also hearing the sound. Me hearing the sound is not preventing you from receiving the benefits of the sound and warning you that there's a tornado. Other examples, national defense. Think about it in what way is this non-excludable? Well, think about maybe if I'm living off the grid or something, and I don't pay taxes, I'm not contributing in any way to the funding of the military or the national defense, and yet just by being here, I am benefiting from being in a safer place. Likewise, it's not rival in the sense that if I'm benefiting from being in a safer place, well, that doesn't prevent you from benefiting as well. Right? We can both receive the benefit of national defense. And finally, another example, an uncongested non-toll road. So it's non-rival in the sense that it's uncongested, and it's non-excludable in the fact that it's not a toll road. We don't have to pay to be on the road. Okay, so let's talk a little bit more about public goods. So in public goods, there's often a problem called the free rider problem that's associated with public goods. Now, consider this example. Okay, so we've got a small town. Maybe it's something like 500 residents. And in this small town, we're considering maybe somebody who works for the local government is thinking, whether we should have a 4th of July fireworks display this year. And let's say that each of the 500 residents places a $10 value on enjoying this fireworks, right, of watching the fireworks display. In other words, in their minds, right, their willingness to pay, right, each person's willingness to pay, they'd be willing to pay $10 to enjoy the benefits of that 4th of July fireworks display. The cost of the fireworks to be able to put on the display is $1,000. Okay, that's the cost of the fireworks, organizing the event and getting all the supplies and everything. So, do you foresee any problems with the private market supplying this good, right? Supplying the fireworks display? Well, I mean, is there some sort of net benefit for society in this case? Well, obviously, yes, right? I mean, if each of these 500 residents values the display, watching the display at $10, well, then the value, the marginal benefit, is equal to 500 times 10. So that's $5,000. And the cost, we've already said, right, is $1,000. Right, clearly, the marginal benefit exceeds the marginal cost. Right, so this is good. Right, the town would benefit. Each person would benefit from being able to see this. So for society, this makes sense. However, the problem with this is that the fireworks display is a public good, in the sense that many people in the town could avoid paying the $10, right, or even paying any of the cost, right, any of this $1,000 cost to put on the fireworks display. They could watch it and they could enjoy it, they'd benefit from it without paying. And that, by definition, is a free rider problem. Right? So we could ask people to donate, right? Donate however much you'd like to donate, so that we could put on this display. But as soon as people realize that they could enjoy the benefits of this without paying for it, well, many would obviously prefer not to pay for it. And unfortunately, when goods like this are left up to the private sector, that is, to say markets, oftentimes fail to supply the efficient amount of a public good. Right? So they typically undersupply public goods. There would probably be some people out there in the town who would end up paying, up to $10 to be able to watch the fireworks display, but arguably not enough, because many people would prefer to max out their own individual net benefit, and they'd say, well, I could pay a marginal cost of 0 and enjoy this thing for which I have a $10 marginal benefit, and so my consumer surplus would be 10. The problem is too many people think like this, and as a result, we end up not being able to afford the cost of the fireworks display, and so we don't end up getting a fireworks display. Now, government can perhaps supply the fireworks, and they could charge everybody a $2 tax. Right? So if they charged everybody a $2 tax for the fireworks, well then that would be $2 times 500 residents. That would be $1,000. And so that would cover the cost of the display. And those watching would all have a consumer surplus of $8. So that's one way in which, I mean, it's a very simple sort of, I don't know how to put this here, a simplified example of a bigger problem, right, in the real world. So it's not exactly a real example, but it pretty much gets at the core of what we're talking about here. I want you to think about a lighthouse. Okay, so think about a lighthouse. And I want you to answer this question. You can pause the video after I ask. So I'm going to say, is a lighthouse, or I should say, let's go back. Okay. What type of good is this lighthouse? All right, I'll give you a few seconds to answer that question. All right, well, I'm sure many of you probably answered in this way. Right? You might have said that a lighthouse is a public good. And economists for a long time have used lighthouses as an example of a public good. And it makes sense. In what way is it non-rival? Well, who are those people that are benefiting from the lighthouse? The people that benefit from the lighthouse are those that are out, navigating ships in the middle of the night or during stormy weather. So if I'm out on a boat and you're also out on a boat and we're seeing the light being emitted from the lighthouse, me seeing that light, is that in any way going to inhibit you from experiencing or from receiving the benefit of the lighthouse? No, right? So it keeps me safe, keeps me from crashing, and it also keeps you safe, keeps you from crashing. So in this sense, it is non-rival. In what ways is it non-excludable? Well, in most cases, the lighthouse has no way of charging those out at sea a fee for using the lighthouse, right? If the lighthouse wasn't there, well, then people would essentially crash and perhaps, die or get injured if the lighthouse wasn't there. But if it is there, then they receive the benefit even if they don't pay, right? So in that sense, it's non-excludable, and you could see how there'd be a free rider problem, perhaps. And if we left this up to the private sector or private markets to supply this, we'd probably see that there aren't enough lighthouses, or there aren't as many lighthouses as would be that would be efficient for society. Okay. But I want to provide a little bit of a historical example of a case where a lighthouse was actually a private good. And maybe not a perfect example of a private good here, but off the coast of England in the 19th century, there were many lighthouses that were privately owned and operated. And one of the ways in which they did this was, or one of the ways in which this was made possible, is that the local harbor in which the lighthouse was located was owned by a single owner. And so let's consider a port, right, in which the port is owned by one particular person. And if the lighthouse doesn't operate, then that would prevent ships from being able to pull into the harbor and do business with the port, which is obviously something that the owner of the port or the harbor wants to take place. And so in this situation, the lighthouse owners would simply turn off the light if the owner of the port didn't pay. And that was a way to avoid the free rider problem and to make the good excludable. Right? So in that way, in that sense, it operated as more closely to a private good than a public good. But obviously the problem gets more complicated, and it becomes more and more like a public good if there's not a single owner of the port, right? There's a big town, big coastal town, and it becomes difficult in that sense to know who to charge or to impose any fees on any one particular person. All right, now I want to talk about a few common pool resources. So some important common pool resources, as I mentioned before: clean air and water, congested roads, and other forms of fish, whales, and other wildlife. Think about what makes all of these both rival and non-excludable. So they're rival in the sense that each of these types of goods could be overused, could be polluted, or these resources could be exhausted by our use, by one person's use or by many people's use. And so, if we're dependent upon having clean air and clean water, but there are many polluters, or if we're all trying to gain access to the road and all of us getting on the road at the same time ends up creating congestion that affects everybody else's consumption of it, or in the case of fish and other wildlife, nobody can be, perhaps these things can be exhausted, they can be, fish could be overfished, or whales could be overhunted, and we hunt them, at a faster rate than they're able to repopulate, and then those common pool resources go away. All of these are non-excludable in the sense that nobody can prevent me from enjoying the clean air, the clean water, or getting on the road, or fishing in a lake, or hunting a whale, or any of these other things. At least not any way that the private market can prevent me from utilizing these things. Now, oftentimes government will step in to prevent people from fishing and hunting whales or getting on the road at specific times, and they'll charge a fee to correct for these types of problems that emerge from common resources or common goods. And the problem that typically arises is called tragedy of the commons. And I'll give you an example of this. So suppose that we have a little pond here, and inside the pond we have a number of fish, right? And we'll suppose that initially there are 12 fish. And let's suppose that we have 4 individuals, and they like to fish. They like to catch fish. Now, there's nothing in the market that prevents anyone from throwing out, casting a net or casting a fishing pole into the pond and fishing out fish. And we'll assume for just simplicity's sake, we'll say that every night, so each night, and we're not going to care about the sex of the fish. All we need, well, this will be an oversimplification, obviously, but we'll say that we just need a pair of fish in order to repopulate, right? A pair of fish every night. Let's just say each pair of fish produce one full-grown adult fish. Okay, so just to say, make the point more salient here. If there are 12 fish in the lake, on the first day, and nobody fishes any of them out, well, that means that there are 6 pairs that night, and in the morning there will be the existing 12 plus 6, so there'll be 18 fish the next morning. Okay, but we'll say that each person fishing, at bare minimum wants to get at least 1 fish a day. Okay, now, according to their own self-interest, each one would like to have even more fish than that. Okay, and we'll see how this would affect the fish population. So what would be a sustainable amount of fishing for these 4 people each day in order to make sure that they always have at least 1 fish available to each of them every day for the foreseeable future? Well, you could probably do the math very quickly and realize that if each of them fishes out 1 fish a day, then that means at the beginning of each night there will be 8 fish remaining, which is 4 pairs. Right? So the next morning, when they come back, there will be 8 plus 4, and there'll be 12 fish again. The fish in the lake or in the pond will continue to restock themselves, being fished out at this rate. However, what happens if any one of these persons wants to fish out more than 1 fish a day? Okay, well, in that case, let's say that this person here wants to fish out 2 fish. Everybody else, for whatever reason, is just fishing out 1 fish. Okay, well, in this case, we'll start out here. So in our day 0, there are, let's say, the change in fish, there's a 0 change, and the total is 12. All right, so day 1, they take out 5 fish, and the remaining at the end of day 1 will be 7 fish. Day 2, they come back, right? How many pairs is this? This is going to be 3 pairs, right? 3 complete pairs. 1 fish is sort of left out of the mating process. And the next day, there will be, whoops, wrote that in the wrong spot. Okay, we'll say there will be 10 total on day 2, and they fish out 5 again. Okay, and, well, maybe I should have, let's see here. Make this a little bit easier to follow along. All right, so we'll say total at beginning and total at end. Okay, there's 12. So they start with 12, 12 minus 5, 7. All right, now day 2, there's 3 added back in, right, so plus 3. So there's 10. They fish out 5 again. There's 5 remaining. Now, 5 is only 2 complete pairs, right? 2 pairs. And before, this was 3 pairs. So, plus 2 on day 3, right? And they fish out 5 again. And there was 7. There's only 2 remaining at the end. And that only creates 1 plus 1 new fish. So by day 4, well, they can only fish out 3 because there's 3. And now by day 4, there's no more fish in the lake. So the problem with the tragedy of the commons is that there's a conflict between self-interest and the social interest. All right. Whereas before we've seen only examples where the free market exhibits, at least under the assumptions of perfect competition, it exhibits this nice efficient outcome where each person pursuing their own self-interest also ends up promoting the social interest. However, in cases where there's a tragedy of the commons, pursuing your own self-interest actually fails to promote the social interest, or it ends up clashing with the goals of the social interest, ends up making everybody, including you, worse off. And that's about where I'll leave it on this lecture.